On the screen, we show a chromatography jar with a tight lid, a shallow pool of solvent, a clean strip of chromatography paper, a pencil line drawn near the bottom, a capillary tube, and a ruler. And the aim is to separate colored substances and calculate their retention factor values. The paper acts as the stationary phase made of cellulose, and the liquid in the jar is the mobile phase, and we choose a solvent that moves the sample without dissolving the paper. A tiny spot of the sample is placed on the pencil baseline because pencil does not dissolve, and the spot must be small and concentrated so the bands are sharp. The jar is covered for a minute to saturate with solvent vapor, because a saturated chamber gives a flat front and better separation. The paper is lowered so the baseline stays above the solvent, and as the solvent climbs by capillary action, the mixture repeatedly partitions between the mobile phase and the stationary phase. A substance that is more attracted to the mobile phase moves further, and a substance that is more attracted to the stationary phase moves less. So the mixture separates into distinct colored bands. When the solvent front is a few centimeters from the top, the paper is removed and the solvent front is marked quickly with the pencil, and the strip is left to dry. The retention factor for each band is calculated as the distance from the baseline to the center of the band divided by the distance from the baseline to the solvent front. We now measure the distances with the ruler, record them in a table, and work out numerical retention factor values for each color. Unknown samples can be identified by running them beside known reference samples in the same solvent and matching the pattern and the retention factor values. If the substances are colorless, we reveal them by viewing under ultraviolet light or by spraying with a locating agent, such as ninhydrin for amino acids, and then we circle the faint spots. Finally, we interpret the pattern, report the retention factor values and the identities, and note quality rules, which are use pencil only, keep the baseline above the solvent, make small concentrated spots, avoid touching the paper, cover the jar to limit evaporation, work in a fume covered for volatile solvents, and dispose of solvent waste safely.